when standard deviation and mean is given to you. So here is a sum where Marius works in a fish shop. 1 week he measures 250 fish before selling them, and length of the fishes is given and frequency is given. Okay, and standard deviation given here 3 centimeter with a mean of 19 centimeter. Now he decides to perform a chi-square goodness of fit test at 5% significant value. So the first question asked here is write down his null and alternate hypothesis. So for null and alternate hypothesis, we will write the lengths are normally distributed with a mean of 19 centimeter and standard deviation of 3 centimeter, and for alternate you will write the lengths are not normally distributed with a mean of 19 centimeter and standard deviation of 3 centimeter. The B part asks us find the probability that a fish is between 9 and 12 centimeter. So here we have to follow the normal distribution steps in GDC, where you go to distribution, you go to normal, and in the lower and upper cases here, you will put a 9 and a 12 with enter the mean and standard deviation and execute, you will get the probability of 0.00939. Now, the C part asks us find the expected number. So, expected number, we know that number of trials into the probability. So, number of trials here is number of fishes which he has taken. So, it is 250 times the probability 0.009, that gives you the expected number of fishes. Okay. The next question asked is D. Complete the table of expected values for 250 normally distributed fish with a mean of 19 centimeter mean and standard deviation 3 centimeter. So, expected value table. So, now how we found out for the first one. Similarly, we have to find out for the rest of the data given here. Now, rest of the data is between 12 to 15, 15 to 18, and so on. So you will follow these GDC steps. For each of the frequencies now, we have to find the expected number as we did for the first one. So in your GDC, you go to menu, stats, and in list 1, you enter the frequency. Okay, the first one frequency was 5 here. So you will enter 5 in the list 1. Then go to distribution, normal, NCD, variable, and in the lower and upper you will put 9 and 12. Put the standard deviation, enter the mean and execute. You will get this probability which you have already done as I showed you previously, 0.009386. Now, after this, we need to calculate the expected. So we enter the frequencies and find the probability, and then after you finish finding the probability normal through NCD, you exit twice. Bring the cursor on list 2 and then go follow these steps. Bars, which is below F3, and then enter F3. After that F6, which is the result. Again come back to F3, F1, which will write a P on your screen. Then enter multiply. After multiplying, write 250 there because this is a survey length of 250 fishes. So when you multiply it with 250 and execute, then you get the answer for this last column here. Okay, so in this way you need to complete this table and write it down. And F question says rewrite the original table and the table of expected values so that all the expected values are greater than 5. Now here you see the last one is 0.9. I need to make it more than 5. So I will add the second last and the last. And here you will add the frequencies. While putting it in your GDC, you will add the frequency of the second last and the last. And the first one you see is 2.35. So you will add the first and the second two. So these are the two frequencies which you will add, because in the whole table, if you see, only the first and the last are below 5. So I need to add the first with the second and the last, second last with the last. How will I add that now? I will add the frequencies. So here, frequency for the first one is a 5 and the second one is 22. So when I add the frequencies, it becomes a 27. So now this is the frequency which I will enter in my GDC. So I'm looking out for length between 9 and 15 and the frequency 27. Similar steps what you have used before for the previous table, you will use here and you will get your expected frequency. So the rest of the things will remain the same. Only first and second which you have added, and the second last and the last when you add, it becomes a 12. So you will get you change the number in the GDC and you will get the answer as 11.92 as your expected frequency. Rest all the steps are same, like how you have done it for the previous table. Okay, so this was all about F, wherein wherever expected frequency is less than 5, I add it with the previous one or the one below it if it is right on top, and I increase the expected frequency and refresh the table again. Okay. The G question is asking for a degree of freedom. Now, data is in this table, it is 5. N is 5. So, our degree of freedom formula will be n minus 1, that is 5 minus 1, which is a 4. Next, they are asking you to find the chi-square value. Now, chi-square, you follow all the steps on the GDC. You go to test chi and it gives you the chi-square value and it gives you the probability, which is 0.856. They are giving you a 5% significance level in the question. They said the probability here in the question, if you see, here in this initial stages, they told us that chi-square goodness of fit test at 5% significance value. So this I will use 5%. I'll convert it into a 0.05. And here they have also given us the critical value, which is 9.488. So probability 0.856 is greater than 5%, which is a 0.05. And chi-square value, I have got it as 1.329, which is less than 9.488 critical value which they have given. So in such a case, we know that when chi-square value is less than critical value and when the probability is greater than the significant, in these two cases, we know that we have to accept the null hypothesis. So this will be my conclusion in the I question. You can write this answer. So this was all about chi-square, finding chi-square when mean and standard deviation is given to you. Okay.